Students, in this video I will go through exercise U6A06B, where I will be solving for the lengths of tangents, secants, and chords. Let's take a look. The instruction for question number 2 reads, find x. Assume that segments that appear to be tangent are tangent. So for question number 2 here, the segments that I'm seeing here is definitely not a tangent. These are chords, and the proportion in which the chords are broken up when they intersect inside of a circle is as follows. You can have x plus 3 times x plus 4 will equal to x times x plus 9. So what will this become? This will become x squared plus 4x plus 3x plus 12 equal x squared plus 9x. Notice that the x squares will cancel, and I can combine like terms. I get 7x plus 12 is equal to 9x. Subtract both sides by 7x, I end up with 3x is equal to 12. Divide by 3, x is equal to 4. Alright, moving on. Question number 3. The segments here are going to be proportional with this relationship. We have the segment on the outside multiplied by the segment of the overall will equal to the length of that segment squared. So this is equal to 6 squared. So if I distribute the 4, I get 4x plus 16 is equal to 36. Subtract 16, I get 4x is equal to 20. Divide by 4, I get x is equal to 5. Alright, question 4. So the segment can be broken up in this manner. I notice that this is 7.5 here, and this segment inside is 4.5. So what I do is I take 7.5, multiply by 7.5 plus 4.5, and this will equal to 5 times 5 plus x. And if I distribute this, or not distribute, if I combine the terms on the left, 7.5 and 4.5, what will that become? That will become 12 times 7.5 is equal to 25 plus 5x. Multiply 12 and 7.5 together, what will I get? Whoops, times 7.5. I'll end up with 90. Subtract both sides by 25. I end up with 65 is equal to 5x. Divide by 5. I'll end up with x is equal to 13. Okay, moving on. So again, very similar. I take 12 times 5 is equal to 6 times x. So I get 60 is equal to 6x. Divide by 6, x is equal to 10. I take 6 times x is equal to 3 times 10. And I end up with 6x is equal to 30. Divide by 6, x is equal to 5. Alright, here, again, x minus 5 times x minus 1 is equal to x times x plus 4. I FOIL the left-hand side. I end up with x squared minus 6x plus 5. Distribute the right-hand side. I get x squared plus 4x. I can combine like terms, eliminate the x squares. I end up with 10x is equal to 5. Or x is equal to 1/2. Which actually doesn't make much sense because I'll end up with negative lengths inside of this. So let me take a moment to pause and look at this. I end with x squared minus 6x plus 5, x times x plus 4. Yeah, that is the correct setup. 10x is equal to 5, x is equal to 1/2. That is the correct setup. However, this is a bad problem because the segments inside will end up being negative. So this is, I want to write that note here. So this is a bad problem because segments are negative. Okay. So again, same kind of proportions. So we say x times x plus 10 is equal to x plus 2 times x plus 7. Distribute the x, I get x squared plus 10x. Foil the right-hand side, I get x squared plus 9x plus 14. The x squares on both sides cancel. I subtract both sides by 9x. I end up with x is equal to 14. Okay. So again, it's the segment on the outside times the overall segment is equal to the segment on the outside times the overall segment. So I say 4 times 8. No, 4 times 12, because I'll write it out. 8 plus 4 is equal to 3 times 3 plus x. So I get 48 is equal to 9 plus 3x. Subtract 9, I get 39 is equal to 3x. Divide by 3, x is equal to 13. Okay. So again, I take x times x plus 6 is equal to 2 times 2 plus 12. So I get 14 times 2 is 28. X squared plus 6x is equal to 28. Subtract both sides by 28. And here I'm going to attempt to factor. Are there two numbers that multiply to 48 but add to 6? So the numbers I'm thinking of, 2 and 14, 4 and 7, does not appear to be so, does it? So in that case, I'm going to try to complete the square then. So I bring over I leave the 28 on the other side. What I'm going to do is I'm going to add both sides by 9. I get 37. And then this becomes x plus 3 squared is equal to 37. Take the square root. X plus 3 is equal to plus or minus square root of 37. X is equal to negative 3 plus or minus square root of 37. However, because there's no negative length, we're only going to take the positive. So negative 3 plus square root of 37. So that's the final answer right there. Okay. Next I have 5 times 5 plus x is equal to 9 squared. So 25 plus 5x is equal to 81. 5x is equal to 66. Divide by 5. I end up with x is equal to 66 fifths. Okay, so again, x times x plus 12 is equal to 12 squared. X squared plus 12x is equal to 144. And is this thing factorable? You know, I am just a little lazy in thinking about it, so I'm just going to complete the square again. X squared plus 12x plus 36 is equal to 180. No, this thing is not factorable. So, because I have to add 36 to both sides, I end up with 180. And then this becomes x plus 6, quantity squared, is equal to square root of 180, plus or minus. This is the next step. That's what it would be. X plus 6 is equal to plus or minus square root of 180. X will equal to negative 6 plus or minus square root of 180. However, x will equal to negative 6 plus square root of 180. So this is the final answer, but I want to reduce the square root of 80 there. Square root of 80 is equivalent to, what is it equivalent to? 90 times 2, or 36 times 5. So 6 square root of 5. So negative 6 plus 6 square root of 5 is the final answer. Okay. All right, so then I have x times x plus 3x plus 5 is equal to square root of 174 squared. I combine like terms. I get x times 4x plus 5 is equal to 174. Distribute 4x squared plus 5x is equal to 174. And again, I am just going to complete the square here. I end up with x squared plus 5/4 x is equal to 174 over 4. X squared plus 5/4 x plus 25th 16th is equal to, so I will need to do the same thing, 174 over 4. So I'm going to go to the calculator. 174 divided by 4 plus 25 divided by 16. 45.0625. So 45 times 16 plus 1. 721. So I guess 721 16ths, and this is x plus 5/4. Actually, no, I made a mistake. So this last number here is not 5. I made a mistake. So this is 25/64. Because I got a half 5/4 and then square it, right? So it's 25/64. So I got to do that again. 174 divided by 4, right? 174 divided by 4 plus 25/64. I get that long decimal, which will turn out to be something ridiculous like that. Okay, so you know what? It's 43.890625. Just going to keep it in decimal. 43.809. What is that? 0.890625. And this is really 5/4, quantity squared. No, 5/8 rather. Is equal to that number, or is equal to the square root of that number. So square root of 6 and 5/8. OMG, it kind of turns out to be something super nice. So 48 plus 5 is 53/8. So that becomes plus or minus 53/8. And x will equal to negative 5/8 plus or minus 53/8, and it will only be the positive version, so it will be x is equal to 48/8, or x is equal to 6. I shouldn't have been lazy. This turned out to be more work than what it really could have been. Okay, so x is equal to 6, regardless. That's the answer. Oh, so next I have 2x plus x times x is equal to 8 times 8 plus x plus 4. I apologize for the grainy image there. And then this is 3x squared is equal to 12 times 8, so that's 96 plus 8x. 3x squared minus 8x minus 96 is equal to 0. Is this thing factorable? Oh boy, here we go. So this time I'm not going to be lazy. Let's see if this thing is indeed factorable. Two numbers to multiply to 96. So 2 and 48, or 4 and 24, or 12 and 8. I think 12 and 8 may be it. Maybe. So if I have 12 and 8, 24 and 12. So if I place 12 here and 8 here, I get 24 and 12. No, that's getting me 12. That doesn't work. So 4 and 24. Nope. 48 and 2. You know what? Quadratic formula. Okay. So this becomes x is equal to 8 plus or minus square root of b squared. So that's 64 minus 4ac. So it becomes plus 4 times 3 times 96. All over 2a. So this is 8 plus or minus 64. 64 plus 4 times 3 times 96. 1216. And is that a perfect square? No, it's not. 1216. So square root of 1216 divided by 6. Is 1216 divisible by 36? No, it's not. 1216 divisible by 2, certainly. Divisible by 2 again, and 2 again, and 2 again. So that's 4. 1216 divisible by 4, of course. 1216 is divisible by, divide by 2 again. Let's see here. 152. 76. So that's 8. 1216 is divisible by 16, divisible by 2, and 2. So 16, that would be 64. So 1216 is divisible by 64. Yes. Okay. So that means this is going to be 8 plus or minus 8 radical 19 over 6. And the final answer will be, the final answer is 4 plus 4 radical 19 all over 3. Only the positive answer there. Okay. And then, okay, so we have a middle guy right here, which I'm going to call Z. So know that z squared is equal to 5 times 5 plus x. I also know that z squared is also equal to 7 times 14. So therefore I can say 7 times 14 is equal to 5 times 5 plus x. So 98 is equal to 25 plus 5x. Subtract 25, I get 73 is equal to 5x. Divide by 5, x is equal to 73/5. Alright, moving on. So I have b times 8 is equal to 6 times a. I also have 4 times 4 plus a plus 6 is equal to 10 squared. So I want to solve for a first. So I end up with 40 plus 4a is equal to 100. Subtract 40, I get 60. Divide by 4, a is equal to 15. And if a is 15, I can then solve for b. So 8b is equal to 90. So b is equal to 98ths, or what is that equivalent to? 45/4. Okay. And then there were 2. So r times 18.5 plus r is equal to 2 times 16. No, 2 times 2 plus 16. So that would be 36 is equal to r squared plus 18.5r. I can figure out r that way. And again, this is nothing that I would like to factor, so I'm just going to use the quadratic formula. Negative 18.5 plus or minus square root of 18.5 squared minus 4ac, so it's going to be plus then 4 times 36, because if I bring the 36 over to the other side, it will be negative, all over 2. So r will equal to, so negative 18.5, actually I'll put no parentheses, negative 18.5 plus square root 18.5 squared plus 4 times 36, all divided by 2. So that's 1.7755. So r is 1.7755. Or, alternatively, if I do minus, I'll end up with the negative answer, of course, so that wouldn't make any sense. So r is equal to that. And I got to find q. So q times q plus 16 is equal to 15 squared. So q squared plus 16q is equal to 15 squared. I will complete the square here. So plus 64 and plus 64. This will become q plus 8 squared is equal to, what's 64 plus 15 squared? 64 plus 15 squared, 289. Is 289 anything? Let me see here. Square root of 289. Whoops. It is. It's 17. Okay. So this is going to be plus or minus 17 is equal to Q plus 8. So Q is equal to negative 8 plus or minus 17. So Q, the only thing that makes sense is 9. Okay, and the last one. So I have two segments here. I have D squared is equal to 9. Whoops. Times 9 plus C. And then I have 9 times 9 plus C is equal to 11 times 26. So 81 plus 9C is equal to 11 times 26. What is that? 286. Subtract 81, divide by 9. Let's see here. Subtract 81. Divide by 9. 22.77777. Okay. And what is that? 22 7/9. So 22 times 9 plus 7. 205/9. Okay, C is 205/9, and to find out what D is equal to the square root of 9 times 9 plus C. So that's what I'm going to do. I'm just going to punch that into the calculator. So square root of 9 times 9 plus 205/9. Because that's what C is. And that would be 16.91. And that's it.